All right, let's do a little talk about linear models. So basically, when you think about linear models, we think of the y equals mx plus b equation, and this does have a purpose, right? So we call this slope-intercept form. So when you see the m in here, M stands for slope, and I'm going to go into more detail about slope on the next slide. This is kind of just our introductory stuff here. The B stands for the y-intercept, which we will talk about on the third slide. And you will notice that we have an x and a y here. Well, x and y represent any point on the line. When you think about linear models, okay, so we have a coordinate plane. A linear model is basically a straight line. So this could be a linear model. X and y represent any point along this red line. And that's why it's just xy, because it could be any ordered pair that satisfies the requirements to fall on that line. So when you're writing equations and we're creating linear models, you're going to come up with a number for m and a number for b. So both of those are going to be numbers. X and y are simply going to be x and y. So you will write y equals a number times x plus a number. Now, with that being said, this over here, the y-intercept can be negative. It is possible to have a negative y-intercept. Just throwing that out there. All right, let's go into more depth on slope. So slope is basically the steepness of the line. When you think about the graph or the line, right, we could have something with a short slope, right, small slope, it's not going up very fast, or you could have something with a really steep slope. So the slope is, you know, the slantedness of the line, if you will. Now, how to think about this, slope is I kind of talk about as the recurring thing. It's the constant, by definition, it's the constant rate of change. Constant rate of change. And the key word there is constant. We have the same thing changing over and over. So you got money in a savings account. You put $20 in every month, $20 a month. That would be the slope. It's the constant change. So if you have something that's happening over and over and over and it's the same amount, that's slope. Now mathematically, if you're given two ordered pairs, so let's say we're given x1, y1, I put ones to note that they're together, and then x2, y2, two ordered pairs. We can find slope, remember slope is lowercase m, by taking y2 minus y1 over x2 minus x1. And I just want to point this out, you can also take y1 minus y2 and x1 minus x2. The big key is that the ordered pairs are on top of each other. So you'll notice here x1, y1, x1, it doesn't matter which one you start with, just so that the ordered pairs are on top of each other. You can also think about this as, some people talk about it as rise over run, because the y-axis goes up and down, right? This is the y-axis, rise, it goes up and down. Run, you run horizontally, that's the x-axis. So y's are always on top, x's are always on the bottom. Okay. The y-intercept is, it's kind of like the starting point. It's a one-time deal, it's where you start. It's also where the graph crosses the y-axis. So if we're looking at a graphical representation, if this is my graph, then this here is my y-intercept, because that's where it crosses my y-axis. All right. So for most of our examples, we are starting at the y-axis, and it's good if you're graphing. That's usually a good place to go. But a big thing to notice, let me get rid of this picture and create a new one here. So this is our y-axis, right? Any point on this line would be considered a y-intercept. The one thing that is true about every point on that line is that x equals 0. So when we're talking about a y-intercept, we know that our ordered pair has to have an x value of 0. For whatever this number is, it doesn't really matter, but if it has an x value of 0, then it's going to fall on this line. All right, let's do an example. So the number of fish in Lake Fishy was 2,100 in 1990 and just 16,400 in 2010. So the first thing we're going to do is find the slope. Now, in order to find the slope, we have to come up with ordered pairs. Now, in thinking about what we just did, in that x, we need x to be 0, I got to figure out where I'm starting. Well, looking at these years, I'm starting in 1990. Therefore, I'm going to let x equal 0 for 1990. So my ordered pair would be 0, 2,100. Our x value generally is, if you have a time period, days, months, years, seconds, minutes, hours, whatever, the time period is usually x. So in this case, because 1990 is a year, that would be our time. It goes in our x value. Now, when I'm looking at 2010, think about the difference from 1990 to 2010 is 20 years. Therefore, the x value for 2010 would be 20. So 20, 16,400. Now I have two ordered pairs. So I can find the slope. So remember, my slope is y2 minus y1 over x2 minus x1. So when I subtract, I end up with negative 3,700 over 20, which reduces to negative 185 over 1. And I like to write my slope as a fraction always, because remember, our slopes have the y values on top, x is on the bottom. Now, when you're interpreting the slope, remember, what do the y's represent? Let me get rid of these spots here. Well, the y values represent the number of fish, right? Look at your ordered pairs. The y's represent the number of fish. The x's represent the number of years since 1990, because 1990 is where we started. So when we interpret the slope, recall, just like with absolute and relative change, if we have a negative, that means we're decreasing. So the number of fish decreased 185 for every 1 year. Well, you don't even really need 4. Every 1 year after 1990, right? So I really like to do this, writing it out. What do my y's represent on the top? What do my x's represent on the bottom? It makes the interpretation a whole lot easier when you're interpreting your slope. And that's, again, why I like slope to be a fraction. Easier to interpret. All right, so let's go ahead and write our linear model. Now, going back to this page, we know that we have the ordered pair 0, 20,100. Therefore, 20,100 is my y-intercept, because that's where an x equals 0. That's where I'm starting. I'm starting in 1990. So my y-intercept is 2,100. We just found our slope to be negative 185 over 1, which simplifies just be 185. Therefore, my my linear model is y equals slope times x plus my y-intercept. So now if you look at this letter D, if this trend continues, so we're going to assume that we continue to lose 185 fish a year, how many fish will be in Lake Fishy in 2030? Well, again, remember, in 1990 we had x equals 0. So in 2030, x will be, well, there's 40 years difference, so we now have x is 40. So y equals negative 185 times 40 plus 20,100. Our first step is to multiply these together, which gives you negative 7,400, add the 20,100, and together we have 12,700. So if the trend continues in 2030, there will be 12,700 fish left in Lake Fishy. All right, let's just do another quick example. Johnny received $50 for his birthday and has decided to save $6 each week in the hopes to buy a new video game system. Now in this one, we have $2 amounts. We've got $50 and $6. So when you're writing a linear model, remember, we need a slope and a y-intercept. So slope is the recurring. What happens again and again, same time period. And the y-intercept, what happens just once. Well, and looking at this, he received $50 for his birthday. That's a one-time thing. Well, he saved $6 each week. That's recurring. So therefore, this is my y-intercept. This piece is my slope. So if I have a b value of 50 and a slope value of 6, then I can write my linear model as y equals 6x plus 50. So how much will Johnny have after 12 weeks? Well, 12 weeks, that's x, right? X is the time period. So y equals 6 times 12 plus 50. Well, 6 times 12 is 72. 72 plus 50 is 122. So after 12 weeks, he will have $122. And the last question for this video, if the new gaming system costs $350, how many weeks will Johnny need to save? Well, recall that the equation is y equals 6x plus 50. Now we're given the total dollars, which we know is the y value. Those 350 equals 6x plus 50. We're trying to find out number of weeks. Okay, so to solve this equation, we've got to get x by itself. So that's the last thing we're going to do. So I first need to get rid of this 50. Well, 50 minus 50 is 0. They go away. So I'm left with 6x on the right, and 350 minus 50 is 300. I divide both sides by 6 to get x by itself, and therefore my answer is 50. So Johnny will need to save for 50 weeks, almost an entire year, before he can buy his gaming system.